Welcome to this session that is going to be a bit special because I won't show you any slides. If you want to see slides, you have many other sessions. Here you are going to see only code, just pure code. So in this session, we are going to develop reactive microservices, and I'm going to use Vert.x for this and deploy them on Openshift, which is a container platform running on the cloud. Well, because I have absolutely no trust at all in conference Wi-Fi, the cloud is going to run on my laptop. But it will be absolutely exactly the same if it will be on Amazon or whatever kind of cloud you are using, hybrid, private, public, whatever. I'm going to use Vert.x. Why? Because, as I said, we are going to develop microservices. We are not going to develop only one microservices, but a set of microservices. Because one microservice is not microservice. If you do one microservice, you have probably a very nice HTTP API, probably not REST, by the way, but just HTTP. That's all. It starts to be interesting when you start combining microservices all together. So it's what we are going to do there. And to do that, you have two ways. You can use a traditional Java EE or Spring way and with thread pools. But if you are doing this, you're actually lying. Why? Because all distributed interactions are asynchronous. And today we reach a point where you really need to embrace asynchronous. So you may think that asynchronous is hard. Asynchronous is complicated code. Asynchronous leads to callback hell. It's not completely wrong, actually. But we are going to see that today we have APIs, we have frameworks that will let you build your system using a very elegant API and stuff like that. So what we are going to develop in the next 45, 50 minutes, it's a shopping list manager. Because you probably all face the same issue I have. My wife has a shopping list, I have a shopping list, and it's not the same. And generally, mine is wrong. Well, or she adds items every once in a while without telling me. So we are going to do that. And for this, I'm going to create a module. I will use Maven. And I will call this module shopping backend. That's fine. Here. And yeah, if you want. And here it is. I have a Maven module, very simple. There is absolutely nothing inside, just a pure POM file. Obviously, I want to extend it to use Vert.x. So for this, we have a Vert.x Maven plugin that is going to extend this POM file and add a couple of things. Should be there, yeah. Vert.x version, the Vert.x BOM, and a couple of dependencies. That one is the only required one to build a Vert.x app, Vert.x core. If you don't have Vert.x core, it's not a Vert.x app. We are going to see those one later. Actually, I just list them in my command line. And the Vert.x Maven plugin here is used to package my Vert.x application. It's not mandatory at all. Actually, you can use the packaging type you want. I'm going to build Fajar because it's easy. But if you want to take this code, the code we are going to develop, and embed it in your Java EE or Spring app, you can, because Vert.x is a toolkit. It's not a framework. It's just a library. So you do whatever you want. You can embed it. You can use it as a standalone application or whatever. So once you have this, let's see if it has imported it. Oh, yeah. OK. So no, first, I need to add one dependency that is missing. I'm going to use slf4j for logging. slf4j, yeah, yes, whatever version. And I need to declare a vertical. So what's a vertical? A vertical is just a Vert.x component, and that's going to be the entry point of my application. And let's call it me Escoffier demo.shopping backend. And this will be a Java class that I'm going to create right now. There it is, that's my Java class. So in Java, a vertical is a class that extends abstract vertical. It has a start and stop method. I just need the start method here. I said in Java because Vert.x is polyglot. I'm going to use Java here because it's probably the language that everybody understands today. But I could have used Scala, Kotlin, JavaScript, Groovy, Ruby, Ceylon, and I'm forgetting some. So check the website, we have the list. So we actually support a lot of language. All of them are running on top of the JVM. That's very important. And when we say we support, that doesn't mean that we use a Java interop layer. That really means that we have the whole API generated for those language using the construct of the language. So depending on the language you will use, the API will look a bit different because the language is different. In Kotlin, or in Scala, for example, you are going to use features. Here, I'm going to use callbacks, and in the second microservice, I'm going to use Rx. So depending on the new language, the API might look a little bit different because the construct and the background of the language are different. So if I take this and I want to develop my first hello world, it will be something like that. Hello, Verso. And I need to listen on a port. So yes. Oh yeah, and that's a bug. IntelliJ recreate. Oh no, only once. They fixed it. So now, once I have this, I can just do Vert.x run, and it should run it. So what I've written here is that I'm just creating a HTTP server, and every time I have a request, I'm going to write as a response, hello Verso. Kind of simple, right? So let's see that. Here is what we have, and every time I'm refreshing, I always have the same thing. So nice, but not that interesting. And we start seeing a bit the reactive thing in the sense that I'm listening for request, and every time I have a request, I react and write the response. Something that is always interesting is to know on which thread we are actually handling this request. So let's print the name here. And yeah, should be fine. Yes. And I don't know if you see on the top, but I'm refreshing, and I'm always using the same thread. Main difference between Vert.x and other systems is that Vert.x is going to use a very, very small amount of threads. Why? Because threads are bad. If you do threads, you do something wrong. Threads are complicated. If you have more than one thread, you are going to have deadlocks, live logs, or messed up with the state of your application. You don't want to do that. You don't want to use synchronize and volatile. Who knows what volatile actually means? They even change the semantic in the JVM between micro version. So you don't want to do that. So what Vert.x is going to do is to say, okay, no problem, we are going to use a single thread. It's called an event loop. Yeah, but it has interesting thing when you do event loop or a single thread is that all your code must never block. Because if you start blocking, then the other requests that will be handled by the same event loop won't be able to be processed because you are waiting for something. So the whole code that we're writing from now is going to be always executed by this thread, but will never block. Because if you block, then you lose your scalability. So what I wanted to do now today is to develop my shopping list system. So for this, I'm going to use a very simple model, which will be a map. The key is going to be my product name, and the integer is going to the quantity. Hash map should be fine, yeah. There it is. And I want a kind of REST-ish or RESTful API. So like if I do /shopping, I want the list. If I do a post on it, I want to add something and stuff like that. So if I start doing this here, that's going to be very complicated code. If pass equal and method equals. No, I don't want to do that. Fortunately, Vert.x comes with a very handy component named Vert.x Web, and Vert.x Web proposed a class that is named router. And on this router, we can register routes. Okay, so for example, when I have a request on /, I will do what I was doing before, which is write hello Verso in my response. Or just hello, just to make it simple. If I call /shopping, okay, I want to get my shopping list. Okay, so I'm going to use a method reference that I'm going to implement after that. In case of a post, I want to do add to list. Post is going to have a payload. The request is going to contain some JSON that tell me which product and the quantity. So I need to tell to Vert.x to say, okay, from now on, you need to have the body handler. So by default, we don't, so Vert.x for performance reason is not passing your body. because body can be big. So you have to add this line to really say that. Let's also do a delete. So when I do a delete on /shopping/ the name of my product, I want to do delete from list. So now it's time to implement all those things. Oh, don't worry about that. Yeah, my code does not compile. He's absolutely right. It doesn't compile yet. So in my get list, I just want to return my list as JSON, because JSON is kind of the lingua franca in microservices. So I would just do get my response, do that, and we provide in Vert.x a very simple JSON utility that will encode my list. It is. My list is encoded as JSON, and I'm going to return the list. Add to list is not going to be much more complicated. Here I want to get the payload, and the payload is going to be a JSON object. So I will do body as JSON. Yes, that is going to be my body. The name of my product is going to be name, and the quantity is going to be an integer quantity, and if quantity is omitted, I would just say 1. Okay, by default it's 1. So once I have this, I just have to put it in my list. And now let's return the list. So to return the list, I'll just do get list. That's all. Because it will execute this one, that will just encode the new list and send it as JSON. Delete from list as a path parameter, its name. So I will just do path parameter, oops, no, path parameter, okay. Name, so this name here is what I've written here. Okay, and I will take my list and remove from that one. Okay, and then just get list. Look at one thing, is that I never return, because return means blocking. I'm waiting for the result. Here I'm just continuing my execution. So now it's compiled, and let's have a look at what we have. This is now, oops. Oh yeah, forgot one thing. Right now we're still executing this. So we need to say, hey, use the router. Actually, we're not going to say use the router, use the accept method of the router. So every time that we have an HTTP request, the router is going to be called, look at the set of routes and say, oh, it's that one that I need to call. And call it. Next request, next thing. No, here we have hello, and if I go to shopping, we have an empty list. So now, if I want to add things like, yeah, coffee, I need lots of coffee. I have coffee now, and because a good breakfast comes with bacon, let's add some bacon. We now have bacons. So fine, great. We have bacon, coffee, so it seems to work, but I really would like to deploy that on the cloud, on something that actually is going to run and stuff like that. So let's do that now. Openshift is a container platform. It's not a cloud, it's not a PaaS, it's really a container platform. What it's going to do is take your application as containers, and it will manage them. So Openshift is actually a distribution of Kubernetes. On the bottom, you have whatever you want. Existing machine, Raspberry Pi, RVS instances, so EC2 instances, or whatever cloud you are, private, hybrid, even Azure if you want, so you can even mix all of them. And all these hosts will have a container API. Generally, it's Docker, but it doesn't have to be Docker. On top of that, we have Kubernetes. So do you know Kubernetes? Yes? Nobody heard about Kubernetes? Odd. So Kubernetes is a big project from a small company named Google. They have quite some experience in managing large-scale container application. They deployed, I think it's more than 1 billion containers. Billion. So they have quite some experience. And they built this experience in a project called Kubernetes. And Kubernetes, what it's going to do is that it's nice to have 1, 2, 5, maybe 10 containers. Everything is fine. What about 100? What about several versions of all of them? Then things start to be really, really hard and wild. So you don't want to do that, and Kubernetes is going to provide an orchestration engine between all those containers. It's going to manage the networking, storage, image registry and service registry, logs and metrics, and also something that I don't like, but it seems to be necessary, security. On top of that, OpenShift is adding two main features, at least from me, from a developer standpoint, build and deployment. Build, because I don't want to build my application myself. I will just give that to OpenShift, and OpenShift is going to build this. And deployment, because I want my application to be updated. Generally, maybe every day, doing some kind of continuous delivery. That looks cool, I really want to do that. But if you want to do that manually, you have the new version, you need to start the new version, you need to then be sure it's ready, then stop the other one, and once, and reroute request, oh yeah, that starts to be complicated, and that's where you have two versions. What about if you are doing 3, 4, 5 different push at the same time? It doesn't really work. And what OpenShift is going to do is rolling update, no downtime for free. In terms of build, I didn't mention it, but there is a built-in Jenkins. So all your Jenkins pipeline can be executed by this. I'm not going to use that today because, yeah, it's my laptop. If I start instantiating Jenkins and stuff like that, it's going to die. But yeah. On top of that, you are going to have our microservice. We are going to use 3 in this demo. So the first time you start OpenShift, things can be a bit more complicated because it has really been designed by ops, and I'm a dev. And while we say DevOps and so on, we are going to have a party and doing beers all together. That's just not speaking the same language. So that just doesn't work that. So the first time you go on Kubernetes or OpenShift, you have YAML descriptor, lots, and you say, oh, I don't want to write a YAML file. So, and lots of entities. The first thing is to understand is that I will have my source code, and I will send this source code to OpenShift. I will have created a build configuration. Then in my first example, is going to be just a Docker file. And when you will find the Docker file, OpenShift will say, hey, there is a Docker file. I know what to do with that. And we'll just build the image. The image will be stored in the Kubernetes image registry. Then, as soon as the image is there, I have a deployment configuration that says, oh, there is a new image here, or a new version of my image, and will initiate a deployment. The deployment will instantiate a set of pods, and a pod is just a group of containers, generally 1. And all my session, all pods will have 1 containers. Okay, so that's the dev pipeline. What about the user pipeline? User will emit HTTP requests that will be handled by an entity called a root. A root is going to delegate on a service. Services are managed by Kubernetes, and it's going to not delegate to always the same pod. It's going to do a round robin. So it's kind of a virtual address, virtual URL, and I'm going to use this to do all my load balancing things, and it will be automatic. And then the service delegate to pods and get the request back. So if I want to do that, in this first example, I'm going to create a Docker file. Yes. Ooh, not here. Hey, come on, here. Here. So my Docker file is very simple. I will just use any Java image. Actually, that one is outdated. Don't use it. No, you need to use OpenJDK, blah, blah. Expose the port 8080, okay. Copy the file jar of my Vert.x app to some directory, and just start it. If you ask about this, it's not because Vert.x is kind of a bad boy sometimes, a naughty boy, is actually try to write in the current working directory, and this is a bad practice. So I just say, hey, anyway, we're in a container, so just write in /temp. When the container is dead, everything is dead, so temp is fine. Once I have this, I just have to run a script, build with Docker. This script is going to launch my Maven clean package, okay, to get the file jar, create a build on the OpenShift side, push all my file to OpenShift. That's what it's doing right now. And on the OpenShift side, if I go to build, I will see it's that one here that is running. And if I look at the logs, it's actually executing the Docker file. I didn't run Docker on my machine. Docker runs on Kubernetes. So that means that all the image and stuff like that are managed by Kubernetes, and the push that you have at the end goes to the Kubernetes service discovery image registry. So once we have this, my script also creates a deployment and a pod, and here it is. We are done. We have a pod. That's the name of my service, and that's my public route. And if I go there, I should have hello. Okay, fine. But if I go to shopping, I have my shopping list, which is empty. So let's add stuff. Script, yeah, populate. So that will be my perfect breakfast, which is eggs, bacon, and coffee. I need as many eggs as coffee, so that's a lot of eggs. But yeah, no, it's on the cloud. It's running on the cloud, and you see my URL here. It's actually really on the cloud, and everything is fine. It's working. Except that if you are using the cloud, you probably want some scalability. And what is cool with OpenShift is that you can play with this button here and just say, I don't want one pod, I want a second pod. It's going to start a second pod. Here, it's running, and so on. And if I'm there, everything is working, so fine. But there is something to know, is that if I take this, I do this. Whoa, you see that? It's an empty list. Oh, here I have my shopping list, empty list. Shopping list, empty list. It's exactly what happened in my real life. Split shopping list issue. The shopping list never match. And it makes sense because right now my shopping list is in memory. It's two different pods, so two different containers. So as it's two different containers, the data is lost. So we need to have a way to share this data. And I'm going to use Redis for this. So let's use Redis. So instead of my list, I want a Redis client. Let's call it client, yes. That is going to be my Redis client, and I will just create a static string key. It will be shopping. So Redis is a key value store. And as I'm not a Redis expert, my idea here is to say, okay, I will just use one key, and the value is going to be my shopping list. That's simple. The issue is that I'm on the cloud, so how do I know where is my Redis? I don't know that. But if I look at my project here, overview, here, I have this service here, which is actually named Redis, and behind it, it's a Redis instance that is running. That comes from Google, by the way. So I want to use that one, but how to do that? Well, Vert.x provides service discovery. So I would just ask Vert.x to do, give me a service discovery instance. The service discovery is extendable, and here I'm using the Kubernetes extension, so when it starts, it will look inside the Kubernetes service registry to find all the services, and will track the services from Kubernetes. So that's very handy, because here, I can just do Redis data source.get Redis client, and I want the service that has a name Redis, dot equals Redis. Okay, fine. And once you're done, just do something. When the service is found, I'm going to call this method here. So this callback here. Obviously, service may not be here, so it may fail. Do. That's fine. Error message need to be very meaningful, and I think this is meaningful. If I have my Redis client, then I just do client dot my result. Well, can I do that in a real Java world? No, because this might be executed by another thread, and then I have my Redis client here, so I may go to a synchronization issue. Right, yeah. But it's Vert.x. Vert.x is single-threaded, so you cannot be executed concurrently, because if you have only one thread, you can execute only one thing at a time. So you don't care, you can do that. So no more synchronize, no more volatile, no more debugging of deadlock at 3 a.m. in the morning. Sorry. So the other thing we see is that we start using callbacks. You may like or not callbacks. We are going to see an alternative to this in the next microservices. So once I have my client, I will just start the HTTP server. Okay. So now I need to change all of this method to use my new client. So delete is hdelete, that's my key. Field name, and when you are done, again, it's a callback. When you are done, you just do get list. Okay, this one is done. Here it will be almost the same as set my key name quantity as a string. It cannot be null because if it would be null, it would be 1. And when it's done, I will just display the list. Okay, and here it's a bit more tricky actually. I will do get all. So it will get the, all the, well, it will get my shopping list actually from that is stored at my key shopping, and I will do, if it's failed, I will just fail, my request, which would generate a 500 error. It's not really great, but sorry. And if it's successful, then I have my JSON object. That is going to be a JSON object retrieved from my from Redis, and I just need to. I don't need to encode it here. I just need to say, well, I need to encode it. But I'm going to see the change. I'm going to encode it prettily. So you will see it's my top level user experience design and stuff like that. It's going to add space. It's done. I'm going to re-execute my script. Again, I can do that. Well, it will rebuild the Maven things, and all the objects that I've created, my build and so on, they're already existing. OpenShift say it's already existing, it's the same thing, so I'm not going to recreate them. So you can re-execute your script, you don't care. So it's going to do a build. We see the build running here. I don't know if you see the spinner here. And here, what we see here is a rolling update. So it starts the first pod, and when it believe it's ready, it will stop one pod and then start the second pod, and when it believe again it's ready, it will stop the second one. Yeah, OpenShift, you need to stop believing because you believe wrong. So that's all. So we don't give him any hints to do that. And we will see how we can help him to make an educated guess when the service is ready. So now if I go back here, it's empty. Because, yeah, well, now I'm using Redis, so I need to repopulate it. Let's repopulate. Again, my perfect breakfast, and now it's pretty. Right? It's very pretty, we have spaces and stuff like that, it's cool. And it works, because if I want to add something else, I don't know, water. Let's get some water. I have water now, so it's pretty cool. So I have my shopping list here, and it's fine. But again, as I said, I want a rolling update that works, that there is no downtime, that OpenShift won't route request to my new application before it's ready. To do that, I'm going to create health checks here. So there is two types of health checks. Readiness and liveness. Readiness, it's when you do a rolling update. So it will ping the new application to the /URL or whatever you write. I would just use / here. And when it's, say, 200, it will say, okay, you're ready. I can start sending you requests. But during that time, it will still use the old version. And that's fine. That's, so there is no downtime. Liveness is just in case your application crash. Because, well, we all know that we have bugs and it may crash. So if the liveness check failed, then it will just restart your application. So if I do that, okay. So as I've changed the deployment configuration, it's considered as a change, so it's doing another rolling update. So it's starting the new one. Now it's ready. It's not ready yet, the second one. And when it knows it's ready, it just, and that's all. And stop the two other one. So if I go back here, that's fine. So just to be sure that you believe me, because you may not really believe me that it works, let's do a very simple hack here. And I just will add here the name of the pod that is handling my request host name. So this is a hack actually. This is not documented in any OpenShift or Kubernetes documentation, so don't use it in production, or use it but don't say, I told you that. So I'm rebuilding it, so we will trigger another rolling update. And during that time, so let's wait until it's doing it. That's the rolling update, and that's the build, okay. New deployment will be automatically once build completes. Rolling update. So if I go back here and I just do get this, so I'm going to make it. So here we're still on the old one. Oh, that's already the new one. We have this header here. Ah, that the second instances is not yet ready, so we still have the old one for the second instances, so that's a new one. Oh, now both are using the new version. And no downtime. Did you see any downtime here? I was continuing doing the query, so there is absolutely no downtime. So that's pretty cool, because there is no downtime. What if we start going to see a pod? So we can have the logs. Ooh, that's logs. We can go to the terminal. We can do a PS. What we do when we have the list of processors or process. Kill min of 9. What's my app? 7. I kill my app because I'm a developer, and as soon as I see a PID, I kill it. That's all. That's my reflex. PID, kill it. Yeah, but seems to be fine here, right? It still says queue here. It says, oh, container restarts. Container restarts. Kubernetes monitor my application, and as soon as my application does not answer anymore, or it's killed, it restarts it. So unfortunately, I have to admit that I can't kill my own application anymore, because this scene is restarting it. So obviously, I kill it there, but imagine an out of memory or stuff like that. You don't really care. Well, you should, but it will restart it. If it fails, you can still connect to an old pod that has been removed to debug it. So you can do such kind of things. Okay, so we have this shopping service, but when I go to my grocery store, I also want to know a little bit how much it's going to cost me. And I found this very nice, completely random pricer services that is here. And I'm going to use that, to use this pricer service, and for every item of my shopping list, I will ask him, hey, give me the price. Very simple. But I don't want to do one item, give me the price, get the price. Next item, give me the price, and so on. I don't want to iterate. I want to say, that's my set of items, call the pricer in parallel, so concurrently, and the pricer will reply to me. I don't care about ordering, and as soon as I have a response of the pricer, I want to write it directly to my HTTP request. So my memory is still very, very light, because I don't have to build the whole payload in my memory. I'm writing it as soon as I have a result from my pricer service. So let's do this. This is this project here that I have started. It's not going to use this Docker approach. It's going to use a Maven plugin that does exactly the same thing, Fabricate Maven plugin. And as the Fabricate Maven plugin knows the Vert.x Maven plugin, as soon as he found the Vert.x Maven plugin, he knows what kind of metadata and objects and how to start the app. So they know each other. And in this one, I'm not going to use callbacks. Because, yeah, you know, callbacks, you probably don't want that. I'm going to use a reactive programming way. Reactive programming is about observable stream of data, subscription, and stuff like that. I'm using Eric Java 1, and Vert.x provide a binding with Eric Java 1. When I say binding, is that all the method we have called, there is an Eric's method that I can call instead of that. So for example, in my service discovery, I want to have the pricer service. So I will do HTTP endpoint. Eric's get web client. As soon as there is a Eric's prefix, that means that it's an Eric's Java method. Here I just pass discovery, and I would just say I want the one that is named equals pricer service. So again, it's a pricer service. Instead of using a callback here, that would be the regular way to do it in a pure Vert.x, it returned me a single. A single is a kind of a features, but it's a bit lazy features in the sense that by default it does nothing. It's really lazy. It's probably French actually. So it does nothing, and when we will subscribe to it, it will execute this code and tell me when it's done. So I need the same thing for the shopping backend, and the name is shopping backend. Okay, and that is going to be S2. Always use meaningful variable name, right? Or do I get those name? That's the name inside my Kubernetes service registry. So this one and this one here. And as it's HTTP endpoint, I'm just using HTTP endpoint. And the web client is just an HTTP client for Vert.x. So now I need to do something when both are found. Wow, if I do that with callback, the two callbacks may be called at the same time, so I need to check whether the other one has been called and stuff like that. So you have at least 4 alternatives here, and then you have just 2 services. So imagine if you have 8 services. So it just doesn't scale. But we are using Rx, so what I'm going to do is just zip S1, S2. And zip is going to call this, S1 is the pricer. This callback here, once both has been, well, successfully resolved, so both have values. And when I have this, is that my pricer is going to be P, and my shopping backend is going to be S. And then I will start my HTTP server because now I'm ready to start. Okay, cool. Again, always executed by the same thread. I don't need to use synchronized, volatile, atomic lock, or atomic reference, or latch, or stuff like that. I don't care. It's just always the same thread, so I'm fine with that. And when I request / here, I'm going to execute this method here. So this method is going to retrieve all the, well, my shopping list. So to do that, I will just do get /shopping dot Eric send. Yeah, it's going to be a JSON object, body as JSON object, and yeah, that's all. That's fine. Here is my single that gets my JSON object. /shopping. I don't have to part the address or port or stuff like that because I found this HTTP client from the Kubernetes service discovery using the Vert.x service discovery. So it's already configured with the right address. So it's fine. I don't care about the port and so on. I just need to be sure that it's /shopping. Once I have this, so this is this line here, I will iterate in a non-blocking way on all the items, and for everyone, I will call the pricer. And once the pricer replies to me asynchronously, I will write directly in my response. So that's what I'm going to write right now. So when I have it, subscribe, that's my JSON. Okay. So JSON is my shopping list. I will create a new observable from that. Okay. And every time that I have an entry, I'm going to call the pricer. So I made a small utility method to do that. It's exactly the same code as here, so don't worry. And I just need a return. And when I have this, I need to subscribe on it, and I have 3 cases here. I have the next product. Why did I do that? Product. So the pricers are return the product. Cool. So, and for everyone is going to call that. So like on next. So here I will just write in my HTTP response the product. So my HTTP response is chunked. So what is chunk? So chunk is not new. Chunk exists since the 90s. It's HTTP 1.1. You don't have to get the whole payload in your memory and write it down to the HTTP request. Even if all frameworks do that, that's not necessary. Chunk means that you can send it by chunk. Yeah, so that's why it's called chunk, actually. So as soon as I have a result, I will write it in my HTTP response. The client, my browser, is going to see that as chunked and do whatever it does with chunks. So my memory stays under control. Pretty cool. And very simple to use, actually. And it exists. You don't need to use WebSockets or stuff like that to do this. So that was as soon as the pricer reply, but it may be an error too. And in that case, I would just fail. Okay. And when we have iterated, well, call the pricer for all the items, so my observable reach the end, this method here, that is incomplete, is going to be called, and I will just end the request. So it can be beautiful, yeah, Matt. Thank you, IntelliJ. Okay. And I'm done. If I run this, it should work. I'm forgetting something? Yeah, here. I remember because last time I forgot to do that. So obviously, if I don't subscribe, nothing is going to happen. And that's it. Yes, that should be fine. So let's deploy this. It's not what I wanted to do. Here I'm using Maven to do that. Fabricate deploy. It's going to connect to my OpenShift instance, do the jars, and find that it's a Vert.x Maven plugin and well, execute it. So it's what it's doing right now, and create all the entities that need to be done, send that to OpenShift. So it's not using a Docker build, it's going to something called S2I, source to image. Worst name ever. So basically at the beginning, when I say source to image, I was thinking, okay, that's my source code, and you want to build an image, so you are going to run Maven on yourself. It's what it does, actually. You could use it like that, but running Maven every time from scratch means downloading internet every time, and you don't want to download internet every time, so you don't want to do that. So there is another way to use source to image to say, well, the source is not your source code, the source is the file jar. I give you the file jar and build an image out of that. And because it knows that it's Vert.x, it knows what kind of image it has to use for running a Vert.x app. And that's what we see here, something here. That's the image that is built, that he has built. So, because S2I comes from this ops background where they knows exactly how to run your application, it's not small. It's not a very simple Docker file. It's a very complicated one. It has a monitoring agent. It does fancy checks and stuff like that. So it has 23 layers, while the other one had 4. But yeah, it's ops, you know. They won't make things complicated. And no, I don't care this. It's that one here, and it should work. Yes! So what we see here is my shopping list. For each item of my shopping list, it calls a pricer, and the pricer gives a price. And as soon as the pricer returns, it writes a line in my HTTP response, which is my HTTP page, my HTML page here. All happen in parallel. That means that I'm not waiting the pricer to return before calling the next one. I'm calling the pricer 4 times in a row, or 4 times in parallel, and I don't care. If the pricer fails, it's his fault. It's not mine. I just don't want to wait until it gets something. I don't want to do sequence. I want to use my CPU for the right thing. So, cool. But, as I said, this pricer may be slow, because it doesn't really like being called like that, very, very fast and stuff like that. So he wants, when he's like that, he starts to be very, very, very slow and delayed all requests of 3 seconds. But everything arrives at the same time here, right? So I will do it. 3 seconds or 5 seconds, I can't remember what I said. So, and boom, why? We see here the advantage of using reactive and parallel call to the pricer, because all requests are emitted almost at the same time, all are blocked on the pricer side by 5 seconds or 3 seconds, and as soon as they are back, released, everything comes back. If I would have used a sequential way to do that, the first request would have waited 5 seconds. The second request would have waited 5 seconds. The third request would have waited 5 seconds. And for this, I would have waited 20 seconds. Well, 20 seconds to get this, that's a bit too long. Or even 5 seconds to get this is a bit too long. So how can we do that? I don't control the pricer. I pick the pricer. I found someone from my team that has developed this pricer that is very good with math.random, because it's just random. So I want to protect this call with something to be sure that I handle timeout and failures efficiently. That's what we call a circuit breaker. So there is a couple of circuit breaker implementation in the Java world. The main one is Hystrix. Actually, Nike has developed one too. It's called Resilience or something like that. There is a couple, and Vert.x has his own one. So the Vert.x circuit breaker is a pure circuit breaker, very close to the Hystrix one. And you just configure it with a name, okay. Whether or not you call a fallback if there is a failure or a timeout, the number of failure before calling the callback immediately without calling the service anymore, the time between which you try to call the service to be sure to check whether or not it's back on track, and that's my request timeout. So what's a circuit breaker? Circuit breaker is just it's not complicated. It's just a state machine with 3 states. You start in the closed state. And in the closed state, you call your service, and everything is fine. But every time you have a failure, the circuit breaker is keeping track of this failure. And when the number of failures reach the threshold, which is here 3, it's going to go to the open state. In the open state, it doesn't call the service anymore. It will execute the fallback immediately because it has realized that your service that you're calling is slow or failed or under stress or in depression, so whatever. It's doing something bad. So, but then there is this reset timeout. And once this reset timeout occurs, it will try to call, so the next request will call the service just to check if it's back on live or back on track or not. If it's not, it will go back to the open state and wait again 5 seconds. And if it's back on track, it will go back to the closed state and restarting calling the service as usual. So circuit breaker is really about respect, actually. You don't want to hammer a service if it's not in good shape. So if it starts to be on his knees, you give it some time to be back on his legs. And as soon as it's back on his legs, you start hammering it again. That's until next failure. So once I have the circuit breaker, I need to use it. So using a circuit breaker is actually very easy. Here, I will use my circuit breaker and I will execute my command, so my operation. My operation is this. Actually, I can just get that code here and pass the future. Yes. This is too much, okay. And then if there is an error, I will provide a fallback value. So I did get back price, and that's my entry. Okay, what do you want? Tac. That one is there. Up here. Return. So it's probably something execute. Price or entry future, yeah. Okay. Yep. This one? Oh yeah. It is. It's working. And let's make it. Thank you. It's kind of hard because I don't see the end of my line here, so it's kind of tricky. So And now my circuit breaker is going to monitor my retrieve price operation. It gets the futures as a parameter, and the future is just there to keep track whether it was a failure or not. That's all. If it was a failure, it will just get a fallback price. If I deploy this again, rolling update again, because I don't want to have downtime to my system, we never know. Where is this one? Shopping list service. It's going to open here. Starting S2I build. Okay. We have the build running here. Oh, by the way, you can see the difference between my very simple applications that has only the port 8080 opened, and this shopping list, because it's an S2I, has the port 8080, but also the port 8778 for monitoring and using Jolokia, and 9779 for Prometheus. So really monitoring stuff. So it's doing the shopping list thing. So don't care about that. It's because when I, as I didn't restart OpenShift this morning, the internal clock is just out of track. So it's thinking that it's yesterday. Okay, so we are back on track, and now if I go that, remember the pricer is still in slow mode. So we will call the first one, the second one, and as soon as there is a timeout, it will just say, well, provide a fallback price. So, and it won't wait for the pricer to return, which actually means that the response is coming but afterward. The none is just a tribute to JavaScript, because JavaScript is cool, right? So not a number. And as soon as I toggle the pricer back to the normal mode, so we are probably in the half open state, here, this one. So we were still in the closed, in the open state. That's the half open state. We try to check whether or not it was successful. It's successful, so if I refresh, now we have all our values. That's all, circuit breaker in 3 lines of code. That's more or less everything that I have to show you today. I've seen quite a lot in these 45, 50 minutes. We have seen how to develop reactive microservices with Vert.x on top of a cloud platform here, OpenShift, but it will work with any other cloud platform, because the features that I've shown here are more or less available everywhere. You may ask why Vert.x? Because, well, it's just a different way of designing your system. If you use a framework, you have to follow the rules of the framework. I don't like following rules. I want to be creative. I want to build and shape my system as I want to be, not following some guidelines or whatever. So Vert.x lets you do that. You are back in charge. You can be creative. You will do failures, yes, of course, but we learn by failures. So that's fine. Again, Vert.x also uses a very small number of threads, and if you use a thread pool approach on a cloud platform, you are going to spend your time switching between threads. You don't get a CPU when you're on the cloud. You get a CPU time. And if you have a lot of threads, you are going to spend time switching between threads, and that time taken on your CPU time, yeah, that's wasted time. Most of your threads are going to block, wait for database or whatever. In Vert.x, you are not going to wait. You are going to use the CPU time efficiently. That's all I have to say. There is another session about reactive, a bit about Vert.x, but mostly about reactive this afternoon. I can't remember. It's 10 past 2. Check the agenda. I will be there normally. So it's called the reactive landscape, and it explains what's beyond this reactive world. What does that mean? We have seen some reactive here, but if you really want to know more about RX, reactive programming, reactive systems, reactive streams, come to this second session. There will be slides, so that won't be code anymore. If you want to contact me, if you have any question, you can contact me to this address here or on Twitter here. That's the Vert.x Google groups. Follow us on Twitter. This is the documentation with everything I've said is written on this website. And 3 weeks ago, we released a mini book that you can download for free from this address. You just need to write a fake name, fake number, and stuff like that. and you will download the PDF of the book. It's Reactive Microservices for Java. It will explain you what Reactive is, how to write code with Vert.x, how to start, and almost what we have just shown with different examples, of course. And that's all. Thank you very much. If you have questions, I still have 4 minutes. Any questions?